The signal in the silencing, the vastness of the cosmos. Silence reigns. Not silence as absence, but silence as presencing, endless ocean of stillness, where galaxies drift like lanterns on a dark sea. Stars flare, burn, and fade. Black holes turn invisibility into gravity's song. And through it all, the universe expands in quiet, like breath that has no beginning and no end. For billions of years, this silence endured. The cosmos was vast, luminous, and yet eerily hushed. Then, without warning, something screamed. Across the abyss, a pulse erupted. For less than the blink of an eye, it outshone entire galaxies. A single burst of light, brighter than the billions of suns around it, then gone. No echo, no trace, only silence again. Astronomers call them fast radio bursts, millisecond flares of energy, so intense they carry more power than our sun radiates in years. Yet their origins remain cloaked in mystery. No stars collapse, no black holes devouring, no supernovas, death throes can fully explain them. They come from nowhere, vanish into nothing, and leave behind only questions. Why would the universe hide such brilliance inside a fleeting whisper? What force of nature can ignite brighter than galaxies, only to erase itself in an instant? Here in the darkness lies a paradox. In the silence of infinity, something once screamed, and the cosmos has never explained why. Discovery phase. In the vast silence of the cosmos, the human ear is deaf. To listen, we build instruments, steel dishes, antennas, vast parabolic ears pressed against the dark. One of these, the Parkes Radio Telescope in New South Wales, has stood since 1961, a solitary sentinel in the Australian countryside, tuned not to light, but to whispers of invisible waves. Its gaze sweeps the heavens, recording signals far fainter than the breath of a candle across an ocean. For years, these recordings were stored, archived, and forgotten. Then, in 2007, a graduate student, David Narkovic, working under the astronomer Duncan Lorimer, began to sift through this ocean of data. What they found would ripple through modern astrophysics. It was a fragment less than 5,000ths of a second in duration. A pulse so fleeting that in real time it would have been invisible to human perception. Yet in that blink, the signal had carried more energy than the sun radiates in several days. A cosmic flare compressed into a heartbeat of static. At first, suspicion was natural. The Earth is loud with its own machinery. Radar, satellites, interference falls, signals haunt every search. The anomaly was tested, doubted, and nearly dismissed as noise. But when its properties were traced, they revealed a story written in dispersion, lower frequencies arriving after higher ones, stretched across the data by their passage through billions of light-years of intergalactic plasma. This was no local echo. This was a voice from deep space. The Lorimer Burst, as it would come to be known, was the first recognized fast radio burst, a discovery both exhilarating and unsettling. For in that fleeting spark lay the revelation that the universe may be far louder, far stranger than we had ever imagined. Chapter No to Scientific Shock in Science. There are discoveries that fit neatly into expectation, like missing puzzle pieces, waiting to be found. Then there are moments when the puzzle itself changes, when a single fragment reshapes the entire picture. The Lorimer Burst was such a fragment. Before 2007, The language of the cosmos, as spoken in radio waves, was well understood. Pulsars ticked with the precision of atomic clocks, their beams sweeping across space like lighthouses in the dark. Quasars and radio galaxies radiated steadily, immense engines humming across millions of years. Even the crackle of the cosmic microwave background, the afterglow of the Big Bang itself, whispered in predictable tones. Radio astronomy was a science of patience, of signals measured in hours, days, even cosmic epochs. But the Lorimer Burst was none of these. It was a shout compressed into a millisecond, a sudden flare that carried the energy of suns yet lived shorter than a blink. The scale was absurd. To release such power in such brevity defied known astrophysics. No supernova behaved like this. No pulsar ticked with such ferocity. No black hole jet erupted so instantaneously. The universe had thrown something entirely new into human perception. At first, caution ruled. Astronomers know too well the tricks of earthly interference. Microwave ovens, passing aircraft, stray electronics all can mimic the signals of the sky. The Parkes telescope, though vigilant, was not immune to these intrusions. Many were ready to dismiss the burst as an artifact, a phantom birthed by the noise of civilization. Yet the signal bore a signature that no local interference could fake. Its dispersion told the tale. Higher frequency waves arrived sooner, lower frequencies later, delayed by their passage through clouds of ionized gas scattered between galaxies. This was intergalactic handwriting, the distortion of a signal stretched across billions of light years. The Lorimer Burst was not a glitch. It was not human. It was born of the cosmos itself. That realization was unsettling. For decades, astronomers had mapped the sky with growing confidence, cataloging galaxies, charting cosmic structures, predicting stellar deaths and galactic collisions. But now, a force had appeared that obeyed no known script. It was as though the universe had spoken a single word in a language no one understood, loud, clear, and impossible to ignore. The implications unsettled more than the data tables. They struck at philosophy itself. If nature could produce such an outburst, what else lay beyond expectation? What other voices might wait, hidden in the static, lost in the oceans of data yet to be sifted? Humanity had believed it was fluent in the rhythms of the cosmos. The burst revealed otherwise. Skepticism endured as it must. Extraordinary claims demand extraordinary evidence. Other telescopes combed their archives, searching for echoes. Some found nothing. Others glimpsed faint possibilities, uncertain shadows of similar bursts. Yet nothing matched the clarity of that first detection. For years, the Lorimer Burst stood a lone orphan signal, impossible to reproduce, impossible to dismiss. The strangeness of its properties only deepened the mystery. Its brightness suggested it was generated by an unimaginably compact source, no larger than a city. Its energy implied catastrophic forces, magnetic fields 1 trillion times stronger than Earth's, or collisions between the densest objects in the universe. But even these extremes felt insufficient. Astrophysicists wrestled with models. Could it be a magnetar, a neutron star wrapped in a magnetic cocoon, releasing a sudden flare? Could it be the death cry of a collapsing star, compressed into radio? Or the moment two black holes collided, shaking space-time and spitting radio fire? Each possibility bent under scrutiny, none entirely satisfying. And then there was the haunting thought, one that science approached with caution. What if it was artificial? Not interference, but intent. A signal sent not by stars or gravity, but by intelligence. The sheer power of the burst suggested it could be detected across galaxies. Could it have been a beacon, a message, a cosmic flare sent by a civilization reaching outward? It was speculation without evidence, a dangerous temptation. But in the silence of the unexplained, such questions could not be banished. The weight of the discovery was not only scientific, it was existential. Humanity's instruments had plucked a single note from the cosmic symphony, and it was like nothing ever heard before. For the first time in generations, astronomers stood before a phenomenon that defied categorization. The sense of certainty in the cosmic order had fractured. The Lorimer Burst was a reminder: the universe is not yet fully mapped, not yet fully tamed by equations and theory. It remains wild, capable of surprises that bend imagination. The burst was not just data, it was a revelation, a whisper from the abyss, declaring that the cosmos still holds secrets too vast to predict. For years, the scientific community remained suspended between skepticism and wonder. The signal was singular, unrepeatable. If it was real, it meant an entire new class of astrophysical events awaited discovery. If it was false, it meant science had been haunted by a phantom. Either way, the impact was profound. In retrospect, the shock lay not only in the burst itself, but in what it represented: a reminder that the universe is not obliged to follow human expectation. It speaks in moments that are sudden, fleeting, and transformative. The Lorimer Burst was such a moment, a 5-millisecond spark that cracked open the familiar and revealed the unknown. From that day, astronomers would listen differently. Every archive, every dataset, every sweep of the sky could hide another such burst. The search for repetition began. Instruments sharpened. New telescopes prepared to listen more carefully than ever before. But the shock of that first signal, the astonishment, the disbelief, the quiet thrill of standing on the edge of the unexplained remains singular. The Lorimer Burst did more than challenge science. It reminded humanity of its place, a species listening at the shore of an ocean, hearing in the crash of a single wave the promise of storms yet to come. Chapter No Treaty, Deeper Investigation. The Lorimer Burst was not the end of the Mystery 8, was only the first knock at the door. Once a signal had been glimpsed, once a fleeting flare had shattered the certainty of what was possible, the search could no longer stop. Astronomers began to comb through archives, sifting through forgotten data with renewed vigilance. As though hidden in the static lay other voices, waiting to be heard. The Parkes telescope, where the first burst was found, was the natural place to begin. Its records spanned decades, vast oceans of radio noise, every byte a potential key. At first, the results were meager faint whispers, ambiguous signals, patterns too entangled with interference to be trusted. Yet, slowly, the catalog began to grow. In time, the Lorimer Burst would no longer stand alone. Others emerged from the silent shore, sharp, bewildering bursts of radio light, each carrying the mark of extreme distance, each erupting with the ferocity of entire stars compressed into an instant. Elsewhere, the hunt spread. The Arecibo Observatory in Puerto Rico. Its great dish, stretched across a natural sinkhole in the mountains, joined the search. From its tropical forest, it listened with unmatched sensitivity, and there two strange signals were found. The Green Bank Telescope in West Virginia followed, a towering sentinel of white steel, tuned to the invisible with every instrument. The pattern deepened. These were not isolated mistakes. The universe was speaking in flashes, and humanity had finally learned how to hear. As the 2010s unfolded, technology evolved for the task. Canada's CHIME telescope, an array of 4 half-cylinder reflectors in the quiet valleys of British Columbia, was designed to map hydrogen in the early universe. But its wide sky coverage and real-time processing made it an accidental oracle for fast radio bursts. Where older instruments caught rare, sporadic events, CHIME began to hear dozens, then hundreds. A new catalog was born. The once singular burst was now a family, a population scattered across the sky. The data was as beautiful as it was bewildering. Each burst arrived, stretched by dispersion, its higher frequencies racing ahead of the lower, its signals smeared by the intergalactic medium like ink pulled across paper. By measuring this smearing, astronomers could estimate distance. The results were astonishing. Some bursts appeared to originate billions of light-years away. The energy required to be visible at such distances was almost unimaginable. For a few milliseconds, a single burst could rival the output of entire galaxies, and yet no two were quite the same. Some were singular, arriving once and never again. Others returned repeating bursts, heard not once, but many times from the same corner of the sky. These repeaters defied the idea of catastrophic one-time events like stellar collapses or mergers. A dead star cannot collapse twice. A collision cannot repeat. The universe was hinting at not one mechanism, but at least two, perhaps many, each cloaked in radio fire. The puzzle deepened with every detection. Theories multiplied. Neutron stars with magnetic fields so intense they twisted space-time itself, magnitude to prominence as a candidate. These stellar corpses, remnants of supernova, could theoretically unleash sudden storms of energy, producing radio bursts of cosmic scale. And indeed, in 2020, a magnetar within the Milky Way was observed producing a weaker cousin of these bursts, lending weight to the idea. But magnetars could not explain everything. Some bursts repeated with rhythms to peculiar patterns that suggested unknown physics at play. Others carried polarization signatures that hinted at environments of staggering violence, magnetic fields billions of times stronger than Earth's, dense plasma tangled around exotic objects. Some bursts seemed tied to the outskirts of galaxies, others to stellar nurseries. The more was known, the less was understood. Colliding black holes, collapsing stars, interactions with dark matter, all were proposed, none decisive. Some scientists dared whisper possibilities beyond astrophysics itself. Could such a signal, sharp and clear across cosmic distances, be harnessed as a beacon by intelligence? The idea was tantalizing, but evidence remained absent. Still, the possibility hovered at the edges of thought, a reminder of how little was known. The CHIME catalog grew. Dozens became hundreds, hundreds became thousands. The sky, once thought silent in these frequencies, was revealed as alive with eruptions. Invisible fireworks exploded across the cosmic expanse every day, every hour, unseen until instruments became sensitive enough to catch them. The universe had always been speaking this way. Humanity had only just tuned in. Patterns emerged, then fractured. Some repeaters produced bursts clustered in short windows, then fell silent for months. Others seemed to follow mysterious cycles, hints of celestial engines turning unseen. A few appeared unexpectedly, close mere hundreds of millions of light years, while others came from the farthest reaches visible. Each discovery was like the brushstroke of a larger picture, yet the picture itself remained elusive. For astronomers, it was a paradox of abundance. The more fast radio bursts were found, the deeper the mystery became. Each detection confirmed their reality, silenced doubts of interference, cemented them as cosmic phenomena. And yet, each new signal brought fresh contradictions. No single theory could encompass them all. To the scientific mind, this was exhilarating. It was the thrill of standing at the edge of the known, with only fragments in hand. The bursts were not noise, they were information. They carried the fingerprints of their sources, the mark of their journeys, the distortions of the matter they passed through. In them lay the possibility not only of understanding their origins, but of probing the structure of the universe itself. For beyond their mystery, fast radio bursts promised utility. Their dispersion measures could map the otherwise invisible gas between galaxies, the intergalactic medium that holds much of the universe's missing matter. Each burst, in its distortion, traced a line across the cosmos. A survey beam fired from unknown engines into human instruments. To solve their mystery was to open a new tool for cosmology itself. But the weight of their enigma was not only scientific, it was existential. Each time a telescope captured a burst, humanity was reminded that the universe is far stranger than prediction allows. These were not the long, steady beacons of pulsars, nor the predictable hum of quasars. They were lightning bolts in the void, unpredictable, overwhelming, and haunting in their brevity. Somewhere, billions of light years away, engines of incomprehensible power ignite for milliseconds, sending out waves that cross eons to reach a small planet orbiting an ordinary star. The bursts carry no message, no intent that can be deciphered, and yet they arrive, unbidden, like echoes from the deep ocean, reminding humanity of forces beyond comprehension. The investigation deepened, but answers remained just beyond reach. Astronomers watched as the catalog grew, as instruments refined, as theories bent and broke under the weight of new data. Each burst was a clue. Each clue was incomplete. Together, they built a puzzle whose borders could not yet be seen. In the silence between bursts, in the waiting hours of telescopes scanning the skies, there was reflection. What did it mean that the universe spoke in such sudden flares? Was this the rhythm of stars in their death throes, the heartbeat of neutron stars writhing under magnetic strain? Or was it something entirely unseen, some new category of cosmic engine still nameless in human language? The deeper the investigation went, the greater the awe became. For in every answer, there was another question, and in every question, another reminder. The universe is not silent. It speaks, and when it does so in voices that bend the imagination. the search for fast radio bursts was no longer just the pursuit of anomalies. It had become a journey into the unknown heart of the cosmos itself, recognition that even in an age of satellites and deep surveys, the night sky still holds mysteries vast enough to humble the human spirit. Chapter No for escalation, mystery deepens. What began as a whisper in the noise soon rose into a chorus. The more astronomers listened, the more the sky erupted in violent flares of radio light, each one a reminder of energies far beyond human scale. A single fast radio burst, no longer an anomaly, could unleash in a fraction of a second the energy our sun radiates over thousands of years. Power condensed into a blink, unleashed in silence across the void. The scale was staggering. To generate such luminosity in milliseconds suggested engines of unimaginable violence, neutron stars under crushing strain, magnetars tearing at their own magnetic bonds, or cosmic collisions so fierce that space itself shuddered. Yet even these titans seemed stretched to their limits by the data. The universe had revealed events at the edge of physics, phenomena that broke the boundaries of the known. And then, in 2012, a new signal pushed the mystery deeper. FRB 121,102. At first, it seemed like the others brief, blinding, and strange. But this burst returned. Weeks later, then months, it erupted again. The same coordinates, the same spectral fingerprints. For the first time, a fast radio burst had repeated. This was a revelation. If some bursts repeated, then not all were cataclysms. A star cannot collapse twice. A collision cannot replay itself. Something else was at work, an engine not destroyed by its outbursts, but capable of firing again and again. The repeater drew the world's telescopes into its orbit. Observatories across continents turned their dishes toward its faint voice. Interferometers linked their eyes, combining signals to achieve extraordinary precision. Slowly, through the haze of intergalactic dispersion, the location came into focus. A small, faint dwarf galaxy, nearly 3 billion light-years away. This was the first time an FRB had been tied to a galactic home, and the choice of home was peculiar. Not a grand spiral, not a luminous elliptical, but a tiny, low-mass galaxy rich in star formation. Around it, astronomers detected a persistent radio source, a faint glow suggesting an extreme environment, perhaps a nebula of superheated plasma, or the aftermath of a supernova cloaking a young magnetar. The discovery challenged every expectation. Fast radio bursts were not monolithic. They were diverse. Some came as single flares, others as repeaters. Some dwelled in massive galaxies, others in small and fragile ones. They were not bound to one kind of birthplace, nor one class of stellar corpse. The mystery widened. And then came the strangeness of rhythm. In time, FRB 121,102 revealed a haunting regularity. Its bursts were not random. They followed a cycle, a 157-day pattern, with windows of activity followed by silence. The idea of a cosmic metronome ticking across billions of light-years unsettled the imagination. No natural model predicted such order. Was the source of neutron star orbiting another body, its emission bent by gravitational tides? Was it a precessing jet sweeping across space like a rotating searchlight? Or was the order itself a clue to something even stranger. Interferometry continued to sharpen the picture. By weaving arrays of telescopes across Earth, astronomers could pinpoint bursts with exquisite accuracy. Each localization revealed more diversity, some tied to galaxies with active star formation, others to quieter hosts, some nestled near galactic centers, others in outer arms. No single explanation fit them all. The deeper the mystery grew, the more it brushed against the limits of astrophysics. If these were natural, then the engines of the cosmos were more violent, more inventive than theory had dared predict. If not, then the implications reached into territory science approached only with caution. A civilization advanced beyond comprehension could, in theory, harness energies to send signals across galaxies. Such speculation remained unproven, unanchored, but it lingered nonetheless, like a shadow in the corner of thought, and through it, all the bursts kept coming. The CHIME telescope in Canada, with its vast sky coverage, began detecting new repeaters by the dozen. Some shared similarities with FRB 121102. Others behaved differently, bursting in irregular clusters or hinting at yet unknown cycles. The sky, once thought silent, was alive with eruptions more common than anyone had imagined. Dozens of bursts, every day flaring invisibly in radio light across the universe. Each new detection brought awe, but also unease. For the more the bursts were catalogued, the more cryptic they became. No unified model could capture their full diversity. Magna explained some, but not all. Collisions accounted for others, but failed for repeaters. Rhythms hinted at orbital mechanics, but the evidence resisted clarity. It was as though the universe had revealed a riddle in its own language, spoken across the abyss, a riddle whose answer could reshape understanding of stars, of matter, of energy itself. In the silence between bursts, reflection lingered. The cosmos was not only vast, it was violent, brighter, louder, more explosive than human imagination had allowed. And yet, it was also more cryptic. The signals carried no message, no decipherable code, only the raw physics of their creation. Still, the effect was profound. To glimpse them was to feel the presence of powers beyond comprehension, forces that lit the universe with fire unseen. In the end, the escalation was not just scientific, it was existential. Humanity had learned that the night sky, when listened to with careful ears, was alive with sudden thunder. Each burst was both an answer and a question, a reminder that knowledge, no matter how deep, stands always on the shore of an ocean still unmapped. The mystery had not narrowed, it had widened, drawing science deeper into the unknown. And with every flare, with every cryptic rhythm from galaxies beyond, the same haunting truth remained. The universe was speaking. The only question was whether humanity would ever learn its language. Chapter No. 5 Theories and Speculations. When the sky erupts with mysteries, science responds with imagination bound by discipline. Each fast radio burst, each flare of incomprehensible power demands an origin. Yet the answers remain suspended between the familiar and the extraordinary. Theories rise like constellations, some luminous with evidence, others faint with speculation. Together, they form a map not of certainty, but of possibility. The most grounded candidates are magnetars, neutron stars wrapped in magnetic fields of almost unbearable strength. A single teaspoon of their matter would outweigh mountains. Around them, gravity compresses atoms into pure nuclear matter, while magnetic forces twist space-time and rip electrons from existence. In their violent youth, magnetars can undergo sudden magnetic reconnection field lines, snapping and reforming, releasing titanic energy in gamma rays, X-rays, and, perhaps, in blinding radio flashes. In April of 2020, one such object in our own Milky Way, SGR 1935 plus 2154, was seen producing a burst akin to a fast radio burst, though weaker. It was the first terrestrial link between the phenomenon and a known astrophysical engine. For many, magnetars remain the most persuasive explanation, cosmic dynamos erupting with fury. Others turn to collisions, neutron-star mergers, events already known to unleash gravitational waves and gamma-ray bursts. In the final moments of spiraling death, as two stellar corpses crash into one another, their magnetic fields may writhe, generating brief but catastrophic outbursts of radiolight. Such cataclysms fit the scale of one-time, non-repeating FRBs, though they falter when confronted with repeaters like FRB 121102. A star can collapse only once. A collision cannot occur again. Black hole-neutron-star interactions provide another path. Imagine a neutron star drawn into the grip of a black hole, its magnetic fields and plasma streams torn apart by gravity itself. The chaos at that boundary could, in theory, unleash signals like FRBs. Yet such events are rare, and they're fleeting. Violence does not account for the haunting rhythms of repeaters. Beyond the stellar lies the exotic. Some physicists whisper of cosmic strings, hypothetical relics from the newborn universe. Filaments of pure energy left over from symmetry, breaking in the first fraction of a second after the Big Bang. If such objects exist, their oscillations or collisions could release bursts of energy unlike anything seen before, perhaps in the form of fast radio bursts. No evidence confirms them, but the bursts, so far unexplained, keep the possibility alive. Other hypotheses wander further still. Could fast radio bursts be technosignatures, footprints of intelligence written in radio fire? The speculation runs deep. Their precision, their brightness, and their reach across galaxies have inspired visions of interstellar beacons, messages encoded in the language of physics. Some imagine vast propulsion systems harnessing radio beams to drive light sails across space. Others envision the leakage of colossal technology, its energy spilling into the void, just as Earth's own radio emissions leak into the night. Most scientists approach such ideas with caution. There is no evidence that FRBs carry information, no patterns of modulation that suggest intent. Natural explanations, though incomplete, remain more plausible. Magnetars, collisions, and exotic plasma processes stand on firmer ground. To leap too quickly toward intelligence risks illusion. And yet, the door cannot be entirely closed. History has shown that the universe often resists expectation. To deny even the possibility would be to forget how little is known. Between the poles of the grounded and the speculative, the debate continues. Each new detection sharpens the picture, but also fractures it, revealing a diversity that resists a single answer. It may be that FRBs are not one phenomenon, but many a family of engines, some natural, some exotic, each masquerading under the same violent light. In this uncertainty lies a strange beauty. Theories are not merely guesses, they are bridges. Across the abyss, attempts to bind human reason to forces of cosmic scale. Some will collapse under evidence, others will endure, but all reflect the profound fact that the bursts exist. They are real, they are powerful, they are beyond easy explanation. The mystery humbles. It reminds science that even in an age of gravitational wave detectors and deep space telescopes, the sky can still reveal phenomena that rupture expectation. The FRBs are not solved puzzles. They are invitations, urging deeper listening, sharper eyes, and the courage to imagine. For now, magnetars stand as the most convincing origin. Yet the diversity of bursts leaves room for more collisions, interactions, perhaps even unknown physics. And at the edges of speculation, the haunting possibility remains that intelligence, somewhere across the abyss, could leave footprints in fire. Whether natural or otherwise, the bursts tell the same truth. The universe is not quiet, it is alive, with sudden voices shouting across billions of years, voices too brief to comprehend, too powerful to ignore. Each flare is both a challenge and a promise, a reminder that knowledge is not an end, but a horizon forever receding into mystery. Chapter nodes 6 scientific tools and ongoing testing to confront a mystery that burns brighter than stars and vanishes in the blink of an eye. Humanity has turned to its most intricate instruments. Fast radio bursts are fleeting briefer than the strike of lightning, yet their power reverberates across billions of light years. To capture such ghosts requires patience, precision, and a symphony of machines built to listen to the silence of the cosmos. The greatest breakthrough came from a telescope unlike any other, CHIME, the Canadian Hydrogen Intensity Mapping Experiment. Nestled in the quiet valleys of British Columbia, it does not resemble the traditional dish pointing at the heavens. Instead, it is 4 vast half-cylinders of steel, fixed in place, scanning the sky not by moving, but by letting Earth's own rotation sweep the universe across its gaze. CHIME was designed to study hydrogen in the early cosmos, to measure the subtle expansion of space, but it became an oracle for fast radio bursts. With its enormous field of view and real-time processing, CHIME revealed what earlier telescopes could only glimpse: hundreds of bursts, erupting almost daily. What once seemed rare was suddenly shown to be commonplace. The sky is alive with explosions humanity cannot see, but can now hear. The flood of detections has sharpened the puzzle. Patterns of repetition, clusters of activity, diverse dispersion, measures all pour from CHIME's data streams. Its discoveries have made FRBs not anomalies, but a field unto themselves, demanding explanation. Beyond CHIME, other instruments pursue the bursts with equal vigilance. Breakthrough Listen, the world's most ambitious search for extraterrestrial intelligence, has quietly turned its gaze to fast radio bursts. Though the mainstream scientific consensus leans toward natural origins, the sheer brightness and precision of FRBs make them tempting candidates for technosignatures. Could some be artificial, the byproduct of civilizations reaching across intergalactic gulfs? Breakthrough listens data has yet to uncover patterns of information or intent. But the fact that FRBs draw the attention of SETI at all speaks to their singular strangeness. Pinpointing their origins requires still more ingenuity. For years, astronomers could only localize bursts to vague regions of sky, far too broad to identify host galaxies. The solution was very long baseline interferometry LBIA technique that links radio telescopes across continents into a single instrument spanning Earth itself. With this network, bursts can be tracked with millisecond precision, sharp enough to place them within specific galaxies, even within particular star-forming regions. Through VLBI, astronomers tied FRB 121,102 to its dwarf galaxy, and later tracked others to massive spirals, ellipticals, and galactic outskirts. The diversity of hosts revealed by interferometry shattered the idea of a single progenitor. FRBs were not born from one cosmic cradle, but many. The investigation is not confined to Earth. Space-based observatories extend the reach. The James Webb Space Telescope, though not designed for radio, can study the stellar nurseries and galactic environments where bursts originate. Future missions may push deeper. The square-kilometer array under construction across South Africa and Australia will dwarf all existing radio telescopes. With its vast sensitivity and resolution, it promises to detect FRBs by the tens of thousands, mapping their distribution across the universe. It will not only expand the catalog, but refine the search for their physical nature. Meanwhile, other frontiers of science converge on the enigma. Plasma physics seeks to understand how magnetic fields and charged particles could produce such coherent, bright signals. Neutron star modeling pushes the limits of matter under unimaginable density, probing whether magnetars can truly account for bursts of such scale. Gravitational wave astronomy, still young, may one day coincide with radio astronomy, catching mergers of neutron stars or black holes that also spark FRBs. The synergy of these fields transforms the mystery from an isolated puzzle into a nexus of modern astrophysics. Yet one goal towers above the rest: to catch a fast radio burst, not only in radio light, but across the spectrum, to see its X-rays, its gamma rays, its optical flash, all at once. A multi-wavelength detection would tie FRBs to their engines with decisive clarity, the way gamma ray bursts were once linked to stellar explosions. The challenge is daunting. The bursts are unpredictable, appearing without warning. But instruments across Earth and space now wait in coordination, alert networks ready to trigger instant follow-up. Each new detection carries the hope that somewhere an X-ray telescope will see the counterpart, or a gamma-ray detector will register the flash. The race continues. Hundreds of eyes scan the skies, human and mechanical, connected in global networks, listening for the next eruption. Each FRB captured is a step forward, yet the horizon remains elusive. The bursts are still too fast, too bright, too strange, but perhaps this is the nature of discovery. The universe does not yield its secrets easily. It forces patience, ingenuity, and humility. The tools of science are sharpening, and with them, the outlines of the truth may emerge. Whether in the form of magnetars tearing themselves apart, collisions shaking the fabric of space, or forces more exotic still, the answer waits. For now, the bursts continue to blaze from across the cosmos, uninvited, unexplained. Telescopes hear them, record them, catalog them. Scientists theorize, simulate, debate. Yet behind every calculation lingers the same sense of wonder that somewhere, billions of light years away, the universe flickers with sudden fire, sending messages not in words, but in light compressed into an instant. And as long as humanity listens, as long as the instruments remain pointed skyward, the mystery endures not as a frustration, but as a promise that beyond every solved equation lies another question, waiting, hidden in the static of the stars. Chapter No. 7 Philosophical Reflection. Emotional close from the beginning. The night sky seemed silent. The stars shimmered in quiet constellations. Galaxies drifted in ancient stillness, and the void between them stretched without sound. Yet, hidden in that silence, the universe was never quiet. It spoke in flashes of impossible light bursts, so fierce they rivaled the energy of suns, yet so fleeting they vanished before the human mind could even register their arrival. Fast. Radio bursts are paradoxes in purest form. They are among the most luminous events ever recorded, but they last only milliseconds. They speak with the voice of galaxies, but whisper so briefly that only the most vigilant instruments can hear. It is as though nature has chosen to veil its greatest power in brevity, to hide the thunder of creation within the smallest cracks of time. Why should the cosmos choose this form of expression? Why should it conceal such violence within such quiet flashes? Science searches for equations, for astrophysical engines and cosmic mechanisms. But behind the theories lies a deeper question, one that touches philosophy as much as physics. Perhaps the universe speaks this way not to hide from us, but to remind us how limited we are. Our lives stretch over decades, our civilizations across millennia. Yet even our greatest vigilance captures only fragments of the sky's deeper song. For every burst humanity records, countless others erupt unseen, lost forever in the void. They blaze across space, pass our planet, and vanish, leaving no trace except in the silence we fail to catch. The cosmos is alive with eruptions, but we hear only a handful, scattered through time. In this way, the bursts remind us of our in despair, but in humility. We are listeners in the dark, straining with fragile instruments, hearing echoes from billions of light years away. And yet, what fragments we do hear are enough to change everything. In a single millisecond, the universe proves it is stranger, brighter, and more violent than our imagination had dared. In a handful of bursts, entire fields of science are born, entire theories reshaped. The brevity of the bursts becomes part of their meaning. They remind us that truth is not always long and steady. Sometimes it is sudden, unrepeatable, and overwhelming. Like lightning in an endless night, there is beauty in this asymmetry. The brightest signals vanish in instants, while the search to understand them may last generations. Humanity pursues ghosts, flashes already billions of years old by the time they reach Earth. Every detection is a message from the deep past, a cosmic postcard written before humanity even existed. To listen is to hear history, not in words, but in fire, compressed into a heartbeat. And in those heartbeats, something larger is felt. Perhaps the universe is not silent at all. Perhaps it has always been speaking in forms so fleeting, so cryptic, that only now do we begin to realize the conversation is taking place. The bursts are not explanations, they are invitations to sharpen our tools, to widen our imagination, to accept that knowledge is always partial, always expanding. They remind us that the cosmos is not only a backdrop for human life, but an active, restless theater, alive with mysteries we have yet to name. The search continues. More telescopes rise, more bursts are catalogued, more theories tested and discarded. Yet, beneath the data lies a constant truth. Every flare, every ghostly millisecond is a reminder of how much remains unknown. The bursts are not obstacles. They are beacons, guiding science toward horizons still unseen. And so the story of fast radio bursts is not only about the universe, it is also about humanity, its hunger to listen, its refusal to turn away from mystery, its willingness to spend lifetimes chasing the briefest spark. We are creatures who build vast machines in remote valleys, who stare at static for years, all to catch a whisper from the stars. In this devotion lies our place in the cosmos, small, fragile, but listening. The end of all reflection, one image remains, a sky of silence, pierced by sudden flashes of impossible light. Each burst a reminder that the universe is larger than its maps, deeper than its equations, stranger than its stories. We are listeners at the shore of a vast ocean, catching echoes carried by waves too vast to comprehend. And in that silence, the final truth lingers in the darkest sky. The brightest signal reminds us the cosmos is alive with mysteries we have yet to name.